All right, so I think this is recording. Let's take a look at these two problems. They're asking us to solve these quadratic inequalities. And we kind of use a combination of algebraic and analytic geometry methods to solve this. Algebra, we try to factor it and find the x-intercepts, but then we look at the graph of the parabola to help us to write the solution set. So the first thing that we do here is ignore the inequality and just make it an equation. And we want to solve that x squared minus 9 is equal to 0. There's different ways that you can solve this, but probably the easiest way is to factor this into x plus 3 times x minus 3 is equal to 0. That gives us x equals negative 3 and x equals positive 3 as solutions to this equation. So let's put that on an x-axis on a number line, and we've got negative 3 and positive 3, and these are often referred to as boundary points or critical points. If you would be looking at other videos or have other people explain this to you, they may use various vocabulary words that you may not be familiar with. I want to determine whether to include negative 3 or positive 3 in my solution set, and that's an easy decision to make because you look at the arrow, and if it's underlined, then that's including these values, and if it's not underlined, if it's a strict inequality like number 8 is going to be, we'll leave those points as hollow points. So now we want to try to determine to shade away from the middle or to shade in between here. That's our two choices, and we look at x squared minus 9 and we recognize, hey, the graph of this is a parabola, and because this coefficient in front of x squared is positive, this parabola opens upward. All right, so now if I want values of x, that when you take x squared minus 9, if I want that to be 0 or negative, well, I've taken care of the 0. If you plug in negative 3 or positive 3, 3 squared is 9 and 9 minus 9 is 0. Negative 3 squared is 9 and 9 minus 9 is 0. These points are definitely my solution set. Pick any point that is between these two values. And an easy point to pick as a test point is 0. If you plug in 0, 0 squared is 0, and 0 minus 9 is a negative number, is negative 9. And negative numbers are clearly less than or equal to 0. That satisfies that equation. If you picked a point, say, that's bigger than 3, like 4, 4 squared is 16, and 16 minus 9 is 7, and 7 is not less than 0. So you can pick test points and plug them in and determine it, or you can think of whether the parabola opens upward or downward, and whether you want the portion of the graph that's below the line, like we do here, or whether you want the portion of the graph that's above the line. So our final answer here, written in interval notation, is from negative 3 to positive 3, including those endpoints. Like I say, you pick any value of x that's between negative 3 and positive 3, and you do this arithmetic, and I guarantee you're going to get 0 or negative. Now, let's look at this next equation. Let's write this in standard form. I've got x squared plus x minus 12 is greater than 0. But I'm not going to jump in and just solve this inequality straight away. I'm going to first find these critical points, these boundary points, by writing this as an equation. Instead of being strictly greater than 0, I temporarily say, well, hey, let it equal 0. And because of this leading coefficient being a 1, this is generally easier to factor. If we couldn't factor, we could use the quadratic formula, but we can see that this factors because we have x times x is x squared, two numbers that multiply together to give us a negative number but add to give us a positive. The larger number in magnitude is going to be positive, and 4 times 3 is going to do the trick. But I need 4 to be positive and 3 to be negative in order for this to work. So this equation has two solutions of negative 4 and positive 3. You've seen that many times. You know that this equation splits into two equations, but it's simply by inspection, you can see that -4 plus +4 gives you 0. And 0 times anything is equal to 0, so that satisfies that equation. Now, I want to put these numbers on my x-axis, and -4 is to the left of +3. This is just a sketch. I don't have to be detailed and put all the tick marks that are in between there. I need to make a decision whether for this to be solid like it was over here in problem 7, or to leave these as hollow points and to exclude those from my solution set. So these critical points, you look at and see if this had been greater than or equal to 12, then I would have made these solid points, but it's not. So I'm going to leave these hollow. Now, in this case, here let's look at the one that we have in standard form. We want the values of x that when you do this arithmetic, it's positive, and positive outputs, positive y-coordinates are above the x-axis. So if we sketch our parabola, and we know this parabola opens upward because our leading coefficient, this 1, is a positive number. Had it been negative, then the parabola would have opened downward. So it's opening upward, and I want the portion of the parabola, I want the y-coordinates to be bigger than 0. I want to be above the x-axis, and that's going to happen when we have x values that are strictly smaller than -4. All of these points to the left of -4, all of those y-coordinates of all of these points, all of the y-coordinates will be positive because you're above the x-axis. Or if you're over here greater than 3, pick a number like 4 and plug it in, and this arithmetic is going to guaranteed result in a positive number. You pick a number like 0, and it's easy to see that -12 is not greater than 0, that these numbers that are between -4 and +3, they result in a number, since you're below the x-axis, and being negative. We want to be positive, strictly greater than 0. So we're ready to write our solution set. Our arrow is shaded, so that's -infinity all the way up to -4. But this time I need an open parenthesis there, not a bracket, because I'm excluding this from the solution set, or I need to be strictly bigger than 3 all the way out to +infinity. So here, in problem number 7, you saw when the inequality was pointing towards the variable here, and you had a leading coefficient that you're going to be in the middle, and over here when it's pointing away, you're going to be away from the middle. That's in general, that's going to be true, except for a few special cases. So hey, I hope that helps, and I will talk to you later. Ask me any questions if you need to. Don't be afraid, or ask other people. Ask someone. Bye.